So good morning, everyone. We're going to start out today as planned with a review for the exam on Friday. As all of you hopefully have realized, the exam review, which I'm showing on I believe I'm showing on my screen here, is already been posted online. I sent an email and the announcement around about that. In terms of guidance for the exam, I strongly stress that the best thing to do is to focus on the material in the exam reviews and then on the questions for the worksheets you've had so far. There aren't going to be a lot of tricks. There aren't going to be any attempts to deceive you. Those questions on the exam are pretty much aligned with what you will expect to see. The exam itself, just to get your bearings, the exam itself has, I think, 30 questions on it. They're all multiple choice, true, false. Fill in the blank of amongst multiple choices. So there's not a lot of things you have to keep in your mind, keep in your memory. It's not something I don't think you need to cram a lot of facts or anything like that. But I do think it's worthwhile if you go through your class notes. Everything is in there and should be fairly straightforward in terms of, at least I hope so, in terms of the exam. So before I go into it any further, just some logistical things. It actually posts at midnight tonight. You can start it as soon as you want to or as late as you want to. And it'll actually close up at 1 o'clock on Saturday to give everyone ample time to do this, no matter what time zone you're in or what your schedules are. You can do it wherever it's least stressful for you. The only caveat I stress this enough is that once you open the exam, it's set up to be 2 hours of being open on the exam. So it is preferable that you complete the exam in one time period. If there's any issues with that, I'll try to accommodate them for this exam. But I do actually ask that you do the exam in one sitting. You're free to use class notes. You're free to write down notes on your exam review. You're free to use your brains. What I don't want is everyone going on tonight at midnight and then getting the questions and then coming back later. So once you go on, it is set for a period of time that you can do the exam. Just like the worksheets, you can do multiple attempts. The difference here, of course, so if you get something, put down an answer, you think it's wrong, you can go back and change it. The difference here, of course, is that unlike the quizzes, it's not going to prompt you to tell you that you missed number 2. You're going to have to just go through the best attempt at answering the questions. So before I actually go through the exam review material, are there any questions from anyone about the exam or the content before we get started? Otherwise, I'll just start going through the review sheet and we can go from there. All righty. So I have someone here asking, is it 2 attempts in the 2-hour time frame? Yes, I actually have it set up to be 3 attempts, so you can change your answer. Again, it won't prompt you to tell you if you're wrong on an answer, so we won't be able to just hit true and then know it's false. But you'll be able to have 3 attempts to get to make sure you're satisfied with your answers. You'll be able to scroll through and check your answers like that. I forgot to say this. I think I'll send an announcement out about this right after the lecture today. But the quiz, the exam is basically posted under the same quizzes module we've been using for all the worksheets, so it should look and feel exactly like that. Okay. So what I'll do is I'll just get started on the exam review in the interest of time, and if there's questions that pop up, I'll try to respond to them on chat as we go along. But population growth is considered the greatest environmental risk facing society. Okay. Okay. So yes, I got this question here about do we have any live lecture Friday? No live lecture on Friday. I'm not going to inundate you with lectures on Friday. You have officially you have the Friday lecture period to do the exam as well, and there will be no lecture again until Monday. But do remember, there is an assignment. I didn't make it through till midnight on Saturday. There is still a worksheet assignment that's due this week. Not to be punitive, not to make this week challenging for you, but because some of the questions on the worksheet tied to this week's lectures from, particularly from Monday, are actually going to, eligible for the exam. So I do encourage you to do the worksheet assignment before you take the exam, because you'll have a chance to see the types of questions I would ask from the lecture on Monday. Okay, but no lecture on Friday. And that'll all be covered in the announcement after class. So population growth is considered the greatest environmental risk facing society. There are still major questions as to whether we have the carrying capacity on planet Earth to have enough water, energy, natural resources to actually have a sustainable planet and manage population, especially if we consider population growth increasing to about, about by 10 billion people, up to about 10 billion people by, 2050 or 2060, something like that. So key aspects of that is that even though the population growth rate is starting to decrease from where it was, which was over a growth rate of about 2 times per year, for growth rate of about 2, the key thing to remember is the population growth is exponentially increasing. Now that might the exponentially increasing population growth is something I want to highlight for you, make sure you remember, and it may show up on the exam. So is population growth exponential? The answer is yes. So why is population growth such a problem? Why, not like we're looking to curtail population growth, but we have to think about the best way to carry this populations. That key issues, particularly when you see mega cities and urban cities developing, pollution, the accumulation of hazardous waste, and also the impact of large population densities when you have natural hazards can lead to overexploitation of resources and an inability to actually adequately build sustainable materials that can, and buildings and things like that, infrastructure that can withstand natural disasters. So all of these sort of factor into the scenario. Obviously, I'm not going to ask you to draw anything on an online exam, but if, again, I'm stressing this for a reason, the general shape of an exponential growth curve, you all should be able to draw an exponential growth curve, up and as we go. We at least visualize that so you can see that in the when you're doing the exam. So I got another question here about the files are available. I've heard this from a few people. It's available on my screen. I've emailed it out and I've sent it out via the assignment link, so that's a PDF in your email attachments. It has not been removed. It's still there, and I will repost it as a different file name again right after the lecture. But I've sent it to you and sent it to all of you in 3 different ways now: assignments, emails, and posting online. I'll repost it again, but it shows up as available on mine, and several people have reported to me that they've been able to access it on the Karma webpage. So I apologize. I'm not really sure what the issue is, but I'll keep sending it out in as many ways as I can. It's certainly still there, and it will remain there beyond when the exam is over. Okay, so moving along to some of the questions in the review. Again, the worksheet questions and the review questions are directly aligned with the exam. So these are the things I want you to really focus on. What is the relationship between population growth and gross domestic product? So that basically says, what's the relationship between population growth and how much the economic value of a country's economy is. And the reality is that gross domestic product increases with decreasing population growth. So basically, what we know is that in more impoverished nations, such as those in sub-Saharan Africa or the Sahel, they tend to have the highest current population growth rates right now, and generally have the lowest GDP rates. Over on the end, so this almost looks like an exponential decay curve. And over here in the far right, the highest GDP, in a plot of growth curve versus GDP, the richest countries have the lowest growth rates. America is a little bit above the low end of the growth rate spectrum, but in general, that holds to be true. The Keeling curve is important that it tracks the abundance of carbon dioxide. So this is starting to get to the idea of how does population affect global sustainability and global environment. And the key here is that once population growth gets too large, even if individuals use the same amount of energy, it leads to rapidly increasing carbon dioxide levels. And the Keeling curve is the curve that is used to track that CO2. Now, important to remember when we think about population growth and CO2 is that that's really not what I just described. Isn't really accurate. Not only has population grown, but actually the per capita or per person use of releases of CO2 and the per capita uses of water and more broadly energy have actually increased. So in light of changing technologies, computers, phones, data sharing, stuff like that, we're actually using more water, more energy, and releasing more CO2 per person than we did 10 years and 20 years and 30 years ago. So that's a really distressing scenario in terms of thinking about global sustainability. Is the fact that we're actually sort of getting a little bit more needy per person, as well as going from 3 billion to nearly 8 billion in the last since World War II. So the next group of questions sort of move into the evolution of the Earth, and I have a series of questions about this. What caused banded iron formations? This seems like a very specific question, but it's highlighting some key events in the evolution of the planet that I want you to be aware of. And really, the key thing here is that the formation of free oxygen by photosynthesis is what suddenly put oxygen in the atmosphere and caused the ocean chemistry to change incredibly. So I will tell you that there won't be a lot of very detailed questions on the evolution of the Earth outside of sort of major events, such as photosynthesis creating oxygen created banded iron formations. So it is something I highlighted in the worksheets, and obviously in the review here. I would recommend that you keep that one in mind. And then what's the effect? We talked about many aspects of global warming and CO2, and we'll talk about this more as the semester goes on. But one of the things we highlighted, in the first few lectures, is that increasing CO2 concentrations actually lead to ocean acidification. Okay, decreasing the pH or ocean acidification. More CO2. I won't test you on the mechanisms, but that dissolves into the ocean's carbonic acid and causes the ocean pH to decrease, which leads to problems with shellfish, and other biomineral things like corals and stuff like that that can be bleached and can be sort of lost because of this acidification. So generally speaking, what technique helped determine the true age of the Earth? You can think of it as radio dating or radiometric age dating, but the decay of radioactive elements with known half-lives and the ability to measure those parent and daughter, or mother and daughter isotopes by radio age dating and radiometric age dating has been you can use those terms interchangeably, has been the key factor in determining the age of the Earth. But what specifically did we use to determine the age of the Earth? And the reality is that the technique that was used initially and has been verified with other techniques since then is that lead isotopes, the decay of uranium, radioactive uranium to stable lead isotopes, lead isotope measurements of meteorites by a professor named Claire Patterson from Caltech that information is obviously extraneous, but that's what was used to determine the age of the Earth by looking at meteorites. The idea being that because of plate tectonics, because of the fact that there was chemical weathering, physical weathering, and the Earth's surface changed, it would be really hard to actually get a timing for the formation of the Earth. But what they recognize is that by looking at a vast preponderance of meteorites, they could sort of reproducibly demonstrate that the age was consistently about 4.56 billion years. And although this isn't on the exam, remember the scatter in that data, the uncertainty in those measurements of 4.56 gave them an understanding of the amount of time it took to create planet Earth and actually have solidified, a solidified planetary body for Earth. So key thing, lead isotopes of meteorites by radio age dating were the key technique used to determine the age of the Earth. Some of the basics here of these elements, these are obviously probably not in the order which I gave you the exam, but they're order of I was thinking about adding to the questions, is the key fundamental aspects of the atoms are protons, neutrons, and electrons. Hopefully that's totally a review for all of you. Protons is positive, neutrons are neutral, and electrons are negative. Okay, so I would probably make sure I have that down. Hopefully you all do already. But protons are positive. They provide the number of protons determines the chemical identity, basically what the element is. Helium, lithium, etc., is determined by the number of protons. The number of neutrons can vary, and they're usually equivalent to or more than the number of protons. They don't change the chemistry. They don't change the designation of what type of element it is. They don't really change the behavior, but they do change the mass, and they lead to something called isotopes of different mass weights. And then electrons, although we didn't talk about this very much, again, negative charge, but they also do determine the chemistry. How many electrons you use determines how it's going to behave in the natural environment. So again, Protons determine the chemical identity. Neutrons are neutral and don't influence chemistry, although they do influence mass. And electrons are negative, and they do determine reactivity in nature. So again, the number of neutrons for a given element will determine what's an isotope of, different isotopes of uranium have the same number of protons, but different number of neutrons. Relevant to the radio dating discussion, a half-life is the amount of time required for half of the radioactive atoms, or we call them the parent or mother atoms, to decay to daughter atoms. So if you're talking about the dating of a meteorite, uranium-238 is one of the isotopes. It decays at the known half-life for about 11 billion years, and basically we can measure the parent and the daughter, but with the time in which half of the parent decays to the daughter is the half-life, and that's what you could use to understand the how many half-lives of a different element will be. How many half-lives different element you can use to set that clock to determine how much age has evolved since the rock, crystallized, something like that. In terms of major incidents in the evolution of the Earth, the moon formed following a major bolide impact. So we know now that the probably very early on in Earth's history, maybe as far ago as about 4 billion years ago, even back to 4.3 billion years, people speculate a major meteorite or a bolide, it could be a comet, we don't really know, we know it was large based on size, hit the Earth and actually caused mass to be ejected into space, which eventually sort of coagulated around itself and formed a moon. And actually, that's thought to be the way that most of the moons in our solar system formed. The alternative being that some moons get captured by the gravitational force, but ours, based on the mass and the size of the Earth, is thought to be related to a bolide impact rather than a capture theory. So, moving on to the evolution of the Earth, what 5 ingredients are thought to be critical for the formation of life on Earth? Those are water, methane, ammonia, hydrogen, and energy. I promise you I will not actually ask you to repeat those 5, but I want you to remember that these are key ingredients of life. As we talked about in class, there's several different experiments people were able to reproduce the predecessor molecules to life, or predecessors to biomolecules, by simply taking those components and adding an electric spark and seeing what was formed. You can create life. If you haven't, certainly won't be an exam, but if you haven't seen the news this week, NASA has announced that they've discovered on Venus, one of planet closer to us than between us and Mercury toward the sun, that they've now believe they found some gases indicating that they have presence of life in the past. So, if you're into exobiology or sort of space science, a lot of people now are looking for evidence of these particular elements and species on planets to look for life elsewhere. So, the key thing to remember here is that we talked about deep Earth and deep time in long ago Earth's history. We recognize, I think I stressed this, that what we know about the Earth's history is somewhat hard to, it gets harder and harder to understand the further back in time we go, because there's less geological evidence, or certainly less fossil evidence. Although what I want that to stress upon you is that, humans are a really recent phenomenon. We're probably not going to be here that long in the grand history of the Earth in some ways. We're somewhat inconsequential in terms of that, but that deep time actually allowed the Earth to start and stop many processes, try out different forms of life, try out different forms of plate tectonics probably. And it's really this deep time, this incredibly long, hard to understand age of the Earth, allows processes like tectonic evolution sufficient time to happen, to evolve, and to lead to the Earth we see today. So I won't test you on that. The only age I think I'll ask you anything about, if I do, is getting an estimate of what the age of the Earth really is. And for just to remind you, that's about 4.56 billion with a B years of evolution of Earth. So key thing that's really compelling to thinking about life being formed in other locations is that, from what we know, simple life developed rapidly on Earth, and actually very quickly. Probably we wouldn't even recognize some of the earliest forms of life as life itself. They're singular cellular elements, prokaryotes, eventually eukaryotes, multicellular, that got more complicated. And it really was through most of the Earth's history, realistically, before we got more complicated forms of life. The key events there are when these simple photosynthetic bacteria can actually start oxygenating the atmosphere. And again, I already alluded to this. The evidence for that is the formation of oxide, iron oxide, banded iron formations all over the global ocean basins at that time. So more complex life, again, relatively recently, the great radiation of complex life was in the Cambrian. That's within the last 600 million years, which is a relatively small percentage by comparison with the total age of the Earth. I remember if we use the example of the human existence, that's the example where we talked about spreading, somebody spreading their arms, full length across, which I know you can't see in the video, and then what you could remove by one nail file on your nail would eclipse the amount of time humans have been alive. So really infinitesimally small compared to the long history of the Earth. The next couple of questions actually move into the structure of the Earth, how the Earth looks, how it's going to behave, and setting us up to understand the Earth. And the key thing here is the core consists of metallic iron. Right, the entire core consists of metallic iron. The inner core is solid metallic iron. So very dense and a solid. The outer core is actually liquid metallic iron. Also is a very high density, and that liquid metallic iron rotating around the core actually gives us a magnetic field, and is important for a lot of things on Earth, other than besides navigation, in terms of just keeping the magnetic field keeps radiation from the sun and the solar and the cosmos away from us. Key difference in the inner and outer core, again, is both metallic iron. The inner core is solid because the increasing pressure causes to be in a solid state. Despite the fact that this outer core is liquid iron, remember that the density difference between the outer core and the mantle above it, even though we think about them both as being sort of semi-molten, is greater than the density difference between air and a brick wall. So that gives you a sense of just how stable in general the core is in terms of not interacting with the mantle and maintaining a continuous evolution of a magnetic field. So in addition to moving out from the core, the next step out is the Earth's mantle. The mantle is actually the thickest of the sections, and the mantle consists of basically iron, magnesium, aluminum, silicate rocks. I won't ask you about that chemistry, but the aluminum and silicate components are actually what causes that decreasing density compared to iron. Outside of the mantle, of course, we have the crust. So the crust consists of a brittle upper crust and a more ductile lithosphere. And remember, where we live as humans, the crust is what you're walking around on today. Nowadays, it has soil and biology and water, free water, and of course that's been the water in the life evolved over the last. Water's been there slowly accreting from meteorites and comets for billions of years, but the crust has evolved. But most of it is shallow, thin, brittle, and it's where we sort of attract, or where we acquire resources. The lower part of the crust, and sort of the lowermost crust and the uppermost mantle, is actually a term we call a lithosphere, and that combines the ductile part of the lower crust. So the brittle crust up here, lower ductile crust, and the very top of the mantle is sort of harder and more lithified and actually more brittle than most of the underlying mantle. And that lithosphere is actually the boundary between the plates and the mantle, on which most of the continental plates, or which continental plates or what forms the continental plates. So lithosphere is named for the ductile lower crust and upper mantle, and those are what create the plates that we move around and think about in terms of plate tectonics. So the mantle has a specific word. It's the asthenosphere. The asthenosphere is the area below this sort of cool upper mantle, or the solidified upper mantle, and it's really where it's highly viscous, and there's a lot of convection that basically moves and distributes heat from radioactive decay, latent heat, and heat of crystallization around the Earth. And even though the lithosphere is what puts the upper part of the mantle and the lower part of the crust is where the plates are and where they move, it's actually the convection of material in the asthenosphere that actually is thought to drive plate tectonics and keep things moving around. So, just again, mantle is comprised of iron and magnesium silicate rocks. The crust is largely consists of aluminum silicate rocks. The iron and magnesium have largely been lost to sediments or recycled in subduction. But the crust, you can think of it as largely an aluminum silicate rock, which is much less dense than the underlying mantle. Okay, so the heat from the Earth comes from three sources. Those are the residual heat from the planet formed, which was trapped in the core and is slowly dissipating out. It provides some of the heat that keeps us warm and habitable on planet Earth. The second is the heat of crystallization. So when those rocks, when the molten rock in the asthenosphere comes up and crystallizes and gets stuck onto the lithosphere, it releases heat that actually helps keep our planet warm. And the biggest of all the heat sources that are relevant to keeping and sustaining life on Earth are actually tied to the heat from the radioactive decay of uranium, thorium, potassium on the Earth. For perspective, the surface of the Earth and the atmospheric and ocean temperatures are obviously controlled additionally by solar radiation, but without these heat sources, it really wouldn't matter how much solar radiation we had, we could never keep the planet hot. And for comparison, the solar radiation is actually a smaller term, even though it's really, really important to our climate relative to these three sources. So, we talked about the fact that the upper solidified part of the crust and upper solidified part of the mantle and the lower ductile part of the crust is known as lithosphere. But again, the lithosphere is broken up into plates. There's about 20 some major plates. There's new ones can be formed throughout evolution of Earth's history, and some will be consumed. Within our current status, 20 is about a good number. I won't test you on that either. But those plates are those individual bodies that move around relative to each other, and along those movements on a spheroidal or a geoid like this, nearly spheroidal Earth, there are three main plate boundaries that we want to consider. Okay, those plate boundaries are divergent when the plates are moving apart, convergent where they're moving together. One's going to go beneath the other depending on the density, and then transform parts that are moving aside of each other. Okay, so I will not test you on things like give me a specific example of a divergent plate boundary or a convergent plate boundary. But I would remember that, for your own edification and also just for keeping these material in your head, is that divergent plate boundaries are commonly mid-ocean ridges where the plates are being pulled apart and the mantle is upwelling beneath it and continuing to drive the expansion of plate tectonics. There's also some divergent plate boundaries in continents. Examples are the East African Rift. In terms of convergent plate boundaries, remember there can be different types of collisions. There can be oceanic continental, which the denser plate is going to go down. In the ocean continental construct, the oceanic plate's always more dense than the continental and will always be subducted. There can be oceanic, where again, the more dense plate is going to be subducted below the other one. Key thing with oceanic subduction is the fact that the density is largely controlled by the fact that when a magmatic body reaches the surface and lithifies and cools, it's originally more buoyant and less dense, and as it cools, it actually becomes it contracts, it becomes more and more dense, and as a result, most of the competition between subducting oceanic plates is dictated by which one is older. And then the other form of convergent plate boundaries are when you have continental collision. Best example of that's the Himalayas today, and really there we don't actually have a very good understanding. It all depends on density. But in that area where it's really light, even today, we have a very hard time differentiating which one's actually going down. We do know there's some subduction and occurring there, just a little bit difficult to understand which plate wins, although we know it'll be dictated by the density. The last transform is the last type of plate boundary. Again, that's where plates are moving aside of each other. San Andreas fault's a really important example of that. In general, transform boundaries are less frequent than divergent and convergent plate boundaries, but we've spent a lot of time with them in this class because of the fact that they lead to a lot of natural hazards, such as earthquakes and things like that related to plate movements. So, key things to remember here. In convergent settings, the denser plate always subducts beneath the less dense plate. So ocean always subducts beneath continental, or older, cooler oceanic crust subducts beneath younger, warmer oceanic crust. Okay. I won't probably test you on the detail of anything beyond the denser plate is going to be the one that's going to go down, but it's good to know things like the oceanic plates are more dense than the continental plates. And then again, divergent plate boundaries are typically associated with ocean ridges or spreading centers. They're mainly in the oceans, but they certainly can be on land. And realistically, those scenarios on land eventually will form mid-ocean ridges throughout time. And then transform faults, to stress it again, are often associated with the greatest seismic hazards because of how shallow the earthquakes are and how much of that energy is dissipated near the surface. I didn't ask any questions about that in the exam, however. Key things about these plate boundaries, this is where geology happens, is the way I like to say it. So earthquakes, volcanoes, mountain ranges, everything is going to be around the plate boundaries. That's where the activity is always where the plates collide. And even though, clearly that's the way we teach plate tectonics and the way I want you to remember it, that doesn't mean there's no activity within plates. It just means that there's much more activity along the plate boundaries. The exceptions to that scenario, which we talked about, Yellowstone and Hawaii, are mantle plumes or hotspots, which are not associated with plate boundaries. But there are some scenarios where there's major volcanic sources, typically caused by instability of the core mantle boundary, where that liquid iron core can kind of cause some thermal variability and create some long-lived, big mantle plumes that can sort of break through the mantle and come into the impede upon the continental and oceanic plates and lead to mantle plumes that can be large volcanics. So Yellowstone, Hawaii, and several other examples are major plumes that are not tied to plate boundaries, and they're sort of the exception to the rule. I don't think I asked any questions about this in the exam, but clearly, this volcanism that we're talking about, volcanism and seismicity and things like that along plate boundaries aren't just for understanding hazards. We actually think that these plate boundaries, in addition to being where earthquakes, volcanoes, and mountain ranges are formed, they actually are also thought to be integral to where we sort of see increases in biodiversity, chemotrophs, and extremophiles and things like that, where the nutrients are brought up and energy brought up by the volcanic activity, as well as the gases such as ammonia and hydrogen, might actually be really instrumental in creating life on Earth. So that's more for your edification than it is about this exam, but remember that it's also relevant for the plate boundaries, also relevant for biology as well. So how do we know plate tectonics existed? Again, we talked about the fact that this theory has really only been accepted since, post World War II, about 1960. It was still about a 50-50 proposition to whether people taught plate tectonics or this old myo-geosyncline theory, which I don't even test you on, don't even remember. It's not. We now know it was wrong. But basically, some of the key aspects of plate tectonics that a lot of people put together is the correlation of the key fossils on both sides of plate boundaries. For example, fossils observed in South America and Europe, or South America and Africa, that were identical and occurred at the same time. We obviously know by the shape of the landforms that it looks like the continents can push back together and fit together. Widespread glaciation observed across the southern hemisphere. When last time we had a Pangea supercontinent, everything was down towards the southern hemisphere, and the southern parts of South America, Africa, and all of Antarctica had glaciation at the same time. And then also, I'm not sure we actually talked about this in as much detail in the class, but is this the age and the patterns of the oceanic ridges that sort of all came together to give us that information? I won't test you on any of this in any great detail, but those are the key parameters that led to our understanding of plate tectonics. And then the rest of the material is all going to be material we got through in the lecture on Monday. So what are the three types of seismic waves? And these are really, I think, the level of the questions I'll be asking. P waves are compressional waves, S waves are shear waves, and R waves, they're called that for radio waves, but they're the near surface waves. I won't, if you know P, S, and R waves, you're fine. You don't need to know even probably the names or the specifics of how they work. But P waves will travel through solid, liquid, and gas. So anything, they have the most energy and they move the fastest. S waves can only travel through solids. They're a bit slower than P waves. Then R waves are just sort of chaotic and are most important because they do most of the damage in near surface rocks and sediments, but aren't really of major importance with regard to how the earthquakes work. They're really difficult to understand. They don't really give us a lot of information with the earthquakes other than we see the amount of damage they do at the surface. So what causes earthquakes? Remember that stress is a function of all the external sources. Stress is a function of all the external forces acting on a body of rock in this example, and strain is the response or deformation to that external. External stress. I'll make sure that's updated on the email. So strain is response or deformation to those things. And then the key definitions I want you to remember with earthquakes is that the focus is the location at depth where the rock breaks or fractures. The epicenter is the point up on the surface where above where that focal point intersects the geoid of the Earth. So if we say there's an earthquake in Los Angeles, California, we're really saying is there's an earthquake at some focal point or some focus below that. The epicenter is the point where above where that earthquake occurs. But the epicenter is really important because in terms of particularly the R waves, those waves can cause a lot of surface damage right above where that occurs. So remember that the vast majority of earthquakes occur between plates. Interplate earthquakes are the most common. It's actually one of the ways we've been able to map all the plates. And most of those occur along plate boundaries. There are exceptions to the rules, but we're going to cover that in the next set of lectures in the next exam. So don't worry about it for now. I'm gonna take a moment here, if no one minds. I'm just going to look through the actual exam questions briefly. If anyone has any questions, feel free to start asking them. I'm going to look through exam questions briefly to make sure there's nothing I missed that I wanted to cover. So if anyone has any questions, please feel free to type them out now. We talked about how CO2 affects the ocean acidification. Again, I want to stress you should know the basic fundamental elements, fundamental particles, neutrons, protons, and electrons. The lithosphere again is basically consists of the lower, more ductile part of the crust and the upper solidified part of the mantle. So I think all the materials we talked about so far: convergent, divergent, transform boundaries. So I'm not seeing any questions here, but so far I think that looking at the exam, I've covered all the major topics that we're gonna see on the exam so far. So if no one has any questions, we can sort of end the review component of today's discussion. One question. I'm gonna go back to the very beginning part of the review here. Population growth is considered our greatest environmental risk. Remember, the population growth is still increasing exponentially. We talked about the general relationship between population growth and gross domestic product. But can anyone remind me of the relationship between gross domestic product and fertility rates in terms of how many more people are born in a given, or specifically how many children are born per woman in a country is what defines the fertility rate. Can anyone tell me the observations we see in terms of fertility rates? That's right.
A lower fertility rate means a higher GDP.
Actually, the first part of your, thank you for participating. The first part of what you said got cut off, at least on my side. So could you just repeat that?
Oh, I was just saying normally a lower fertility rate means a higher GDP.
That's right. There's a negative correlation. Higher the GDP, lower the fertility rate. That's exactly the case. So very good. Negatively correlated. I think I've gone through the quiz here and the review sheet, and of course I'm not telling you the specific questions, but again, I think to stress, they're going to look very much similar to questions you got on the worksheets and questions asked on the review sheet. So if you're comfortable with those materials, I guess I don't necessarily feel a huge reason to draw it out. Again, key things about the evolution of the Earth's history that we highlighted. We're thought to form from a protosolar nebula. We formed and cooled relatively quickly. It took also a pretty short period of time, relatively speaking, to start life, although it definitely doesn't look like what we think of it now. We know early on there was a lot of bombardment that led to our moon formation. And really, most of Earth's history, about 4.56 billion years till about 600 million years ago, was largely failed attempts at getting meaningful life started. And we really didn't get to anything more complicated than, very simplistic, singular and multicellular bacteria until probably around 600 million years ago. One of the things I was gonna highlight is that in terms of the life evolving, based on what we know about it, is one of the major occurrences on Earth are the occurrence of is the occurrence of mass extinctions. And I brought up the idea of mass extinctions. Remember, the key thing there is that the mass extinctions are known to basically remove large percentages of life on Earth. The largest mass extinction is the Permo-Triassic boundary, which eradicated more than 95% of life. Another key aspect in terms of thinking about life evolving on Earth is that it's often wiping out most of life on Earth that opens up the ecosystem for major biodiversification, major flourishing of new radiation of life. So one of the parts about the evolution of the Earth I didn't see on here, and I'll add this in the review before I repost it, is the fact that you often see mass extinctions leading to major radiations of new life form, not new life forms, but new evolutions of life, and a lot more biodiversity. And again, there have been about 6 major mass extinctions throughout Earth's history. The most large of which was most prominent of which was the Permo-Triassic boundary, which occurred incidentally 252 million years ago. So are there? So there's no penalty for using the attempts. I got that question here, and that's correct. But to clarify, it's not. There's no penalty for if you want to change your answer, you can go back and do it up to 3 times. But again, the only thing that's actually recorded in your grade is the last attempt you take. So the last attempt's the one when you submit it. That'll be the one we'll be grading you on. And the key thing here to remember is that, unlike the worksheets, it's not going to tell you if attempt 1 was actually problematic. So but your final guess, which hopefully will be your best out of the 3, is the one that's going to determine your grade. And really, the only reason there's multiple guesses, multiple attempts allowed, is just directly to make sure that if you have any errors, you if you rethink a question, you have a chance to go back and do that. I don't want to penalize anyone for formulating a guess and then deciding better on it. So. Okay, any other questions? I'm going to be available if there are questions, but what I'm going to do is email out the worksheet here. The review sheet here again. And given that we're already at 9:52, I'm not going to start going back to the seismic lecturing. But to reiterate, the exam will post. The exam has 30 questions. They're all multiple choice or true false or fill in the blank for multiple choice. You can have up to 3 attempts to actually change any of them, so you'll have plenty of time to do the exam. When in normal times when you're all in the class together, I'll tell you that on exam days, most people were done with the exam in well less than 30 minutes, actually. The exam questions have changed since last year, so don't bother trying to find old friends that had it, but there's some commonality in the material, obviously, so a lot of the questions are similar. So I don't expect to take too much longer than that for anybody. Everybody will have 2 hours to do the exam unless you've made an accommodation ahead of time. The exam will post tonight around midnight, scheduled for 12:01 a.m. tonight. Hopefully that goes off without a hitch. I'll stay up to check that does. Will be available till 1 o'clock on Saturday. So the only time constraint you have of relevance is that once you start the exam, you have a fixed amount of time to finish the exam. Okay, so that's the only time constraint, is you have 2 hours, or if you made it special accommodations, ahead of time, you can have more, but 2 hours to start, 2 hours once you start to finish the exam. The only thing I ask is that when you sit down and do it, you do it. If you want to have open book, you want to have open notes, I'd particularly say it's worthwhile to have your worksheet questions and answers and your review sheet questions and answers with you if you're going to have any notes, but you're more than welcome to have your lectures. I'm just going to declare it open book. I prefer you don't just Google all the answers, just to make sure you try to learn something, but obviously I'm not going to be in your dorm rooms or apartments to check on that, but I prefer you don't do those kind of things. The only other class-related requirement for this week is that remember that the worksheet for this week, which has several questions tied to reviewing for this exam by design, is available online now and is due. I made it due by Saturday, so everyone wouldn't be too stressed about finishing the exam. But I do prefer that. I do prefer that you try to do that ahead of time, just because it helps prepare you for the exam. I see your question about do we need to download a proctored system for the exam? No, the exams are going to be taken just on the quizzes tab of Carmen, just like all the worksheets that we've done so far. There's nothing you need to download. I'm not going to spy on you while you're doing the exam, nothing like that. Simply log into the Carmen page, as many of you demonstrated, as all of you demonstrated, you can successfully do to do the worksheets. And under the quizzes tab of the where the worksheets are, you'll see exam 1 posted, and it should be graded and scored, and you should have your grades back by, at the very latest by Saturday. Again, there are 30 questions on the exam, all multiple choice, short answer, in terms of like pick A, B, C for different answers, or multiple choice answers to the question. So that's all for me. I'm going to stop recording. I will stay on the Zoom, both audio, visually, and on chat for a while if anyone has any more questions. But I'm going to stop the recording. So I'm not just sitting here looking at myself. And if anyone has any more questions, let me know. I know the review sheet was sent out via assignments, email, and on the files page. I know that many people have been able to report being able to get it. I'm not totally sure why it's not being able to be downloaded by some, but I'll repost that and resend it so that it's everyone has it. So I was asking, will you be able to see the grade immediately to submit? The answer is I actually think so, but this is the first time I've done a full long exam. I do think you'll actually get your grades immediately when you submit, but I know if not, I'll post them by Saturday. So you should have them as soon as you submit. That's correct. I just haven't actually worked with that yet. So I haven't done it on a full exam yet. I think that's the case though. If not, I will be able to grade them by Saturday.